Hello student, the question says if an electron and a proton possessing the same kinetic energy enter an electric field in perpendicular direction, the path of the electron is more curved than that of proton. He's saying the path of the electron is more curved than that of proton. Electron forms a larger curve due to its smaller mass. So let us see that. So imagine a charged particle Q is going in this direction with velocity v. And suddenly, let us assume there is an electric field in this direction. So there is an electric field in this direction. So as soon as it gets exposed to this electric field, so the particle might curve in this direction. If it is a positive charge, it will curve in this direction. If it is a negative charge, it will curve in the opposite direction because the force on the negative charge is opposite to the direction of electric field. So here, let us say the particle has somehow entered and it is curving in this direction. We need to find the radius at this instant. So at this instant, so let us take this is the instant. So we need radius of path at this instant. If we need to find, we can clearly see velocity is in this direction, the force is in this direction at the given instant, at this instant. Okay, later on these might change, but right now this is the velocity and force direction. Both are perpendicular to each other, so we can say this force is like a centripetal force, and we know centripetal force is equals to m into v square by r is the radius of the curved path at that instant. So this centripetal force can be written as q into e equals to m v square by r. Now we have to bring kinetic energy into this equation because he is talking about same kinetic energy. So I can write Q into E is equals to half mv square is kinetic energy. I can write 2 times the kinetic energy divided by R. So finally the radius is equals to 2 times the kinetic energy divided by Q into E. Everything is vectorial here. E is the electric field at that location. For our given problem, the kinetic energy is same, and not only that, it is entering the same electric field. Since kinetic energy is constant and electric field is also constant, I can say the radius of curvature is inversely proportional to Q. Finally, we got radius of curvature is inversely proportional to Q. Based on this, let us try to answer this question. We got radius of curvature is inversely proportional to Q. The path of the electron is more curved than that of the proton. So the path of the electron is more curved than that of proton. We know the charge of the electron and charge of the proton are both same. So to say more curved is actually wrong, because charge of electron is equals to charge of proton, which is equals to E, their magnitudes. So both would have the same curve, assuming both have same kinetic energy. Remember this. This is also one of the condition. So this is wrong. Next, electron forms a large curve due to its small mass. This is also wrong. Electron does not form a large curve due to its mass. Both will have the same charge. So none of them would form a larger curve. So we can say A and R are wrong for this given problem. Hope you understood how I have solved this. So this is the expression that we get. So thank you.